This is lesson 102 in Saxon's Algebra 1/2, the second edition. This lesson is on multiplying exponential expressions, or expressions that have exponents. This is a really easy lesson. I think you're going to find it easy. We're going to do several problems. I'm going to explain it, and then we're going to do your practice. Okay, so this, when you see this, you know that you say that is 3 to the 5th power. And what it means is that 3 is multiplied by itself 5 times. All right, when you see this, 3 to the 5th times 3 squared, what that means is 3 5 times 3 2 times. So 3 actually is written out as a factor a total of 7 times. And if you see, 5 plus 2 is 7. All right, first problem says simplify 5 squared times 5 cubed times 5 to the 4th. So what that means is 5 used twice here, 5 used 3 times here, and 5 multiplied by 5 4 times here. When I add all that up, 5 is used as a factor 9 times. What I also can do is say 4 plus 3 is 7 plus 2 is 9. See how easy that is? Okay, this says simplify 10 to the 15th times 10 to the 17th. Now, instead of writing this out 10, 15 times and then 17 times, I'm simply going to add the 15 plus the 17 and know that that would equal 10 to the 32nd power. All right, now 2 to the 3rd times 5 squared, you've got 2 times 2 times 2 times 5 times 5. This cannot be solved by simply adding the exponents because the bases of those exponents are different. So I just can't add the 3 and the 2 because this is a 2 and this is a 5. So they're really not like terms. The bases can't be they're not the same, so these can't be added. All right, so variable bases. Since we know that letters in algebra actually stand for numbers, all the rules for numbers are also going to apply to letters. So if we write x squared times x cubed, what we mean by that is x times x, which is x squared, times x times x times x, or x cubed. So here we've used x as a factor 5 times, and we can write this as x to the 5th. What we call this rule is the product rule for exponents. In other words, we multiply the exponential expressions that have the same base simply by adding the exponents. All right, so let's look at these problems. X times x squared, y to the 17th times x to the 4th times y to the 6th. All right, remember when we're doing adding like terms, this is sort of the same. You can only add the exponents who have the same base. Now we have 3 x terms. One is to the 1st, one is squared, and one is to the 4th. And then we have 2 y terms, y to the 17th and then y to the 6th. So what I can do is add all the x exponents, which equals 4 plus 2 is 6 plus 1 is 7. So I have x to the 7th, and then y, I have 17 plus 6, so that's y to the 23rd. All right, let's simplify this one. My a terms I'm going to put a 1 right here. I have 1, 2, 3, and then 4 here. So I have a to the 7th power. And then m, I have 6 plus 5, which is 11, plus 1 more, which is m to the 12th power. All right, let's do some practice. Only have 4 practice problems today. In A, we have actual numbers, and they all do have the same base. Now, I'm going to put this 1 right here, 3 to the 1st, times 3 squared times 3 to the 5th. So I'm going to add those exponents. I've got 5 plus 2 is 7 plus 1 is 8. So this really is 3 to the 8th power. Alright, now in B, I've got letters, which stand for numbers, we know. So I've got 1, X has 1 here, another one there, that's 2. 5 here, 2 plus 5 is 7, plus 2 more is X to the 9th. And then Y, I've got 1 here and 3 here, so I have Y to the 4th power. Alright, in C, I've got A to the 1st, right here, plus A cubed is A to the 4th, plus another A to the 4th right here, is A to the 8th power. And then B, I have B squared plus B plus B. So I have a total of 4 with the B. Alright, in D, I've only got one X term, so I can just bring that down. It's X squared. But then I need to add my Y's. I've got 1 here, 1 here. I've got 1 and 3 is 4, plus 1 is 5, plus 4 is 9. See, I told you that was easy. Good luck. I'll see you next time for lesson 103.